Hello guys, welcome back to my YouTube channel. So in this video we are going to complete the wedge modeling. So in last video we have complete the wedge modeling up to bottom dome slab, and now we are going to continue from here. So this video is going to very interesting. Please watch the full video, and who are new in my channel, please subscribe my channel. So let's start. Now first I'm going to create a groove for this plate member. So just press Ctrl plus G, and now here create a groove. Say I'm naming this groove is as a bottom dome, and select type should be plate, and click on OK. And now click on plate cursor and select all this plate, and now just associate it. So as you can see, all the plate member are associated in this groove. So now I'm going to provide the thickness for this plate. So I'm going to select all this plate, and now just click on this property page and click on this thickness tab, and here you have to provide the thickness of this plate. So in this drawing you can see the thickness of the bottom plate is varying. Here it is 200, here it is 250. Either you can provide the average thickness or you can take the minimum thickness, because you know when we are designing, our design structure should be in conservative side. So that's why if you consider the lowest thickness value, so it's mean if the structure safe in lowest thickness value, then it's okay. So that's why you may consider this lower thickness value, which is 200. So that's why I'm going to provide here lower thickness, which is 200. If it is not safe in 200 millimeter thickness, then we can increase the thickness, obviously. That we can understand after when we'll complete the design, right? Otherwise, right now initially we have to assume some thickness. Say we are assuming this thickness is 200 mm, and now I'm going to click on this assign, and now you can see this property is assigned to this plate. And now just close this, and you can press Shift plus X to remove this property name from member. And just I'm going to close this, and now click on this render view, and here you can see the property is assigned. Now I'm going to create this conical shape wall. So here you can see the base diameter of this conical shape wall is, which is 7.04, and the diameter at the top it is 12 meter plus 0.25 meter, so it will be 12.25 meter. So these two data is required to create this conical shape wall. Now I'm going to open structural wizard. So click on this geometry and then run structural wizard, and here you have to select surface plate and model. Then you have to select here cylindrical surface, and here you have to provide the length of the cylinder, and this data also required. Here you can see the height of this conical shape wall is 1.7 meter. So now I'm going to open it again. So here it will be 1.7 meter, and here it is asking the start radius, so that will be 3.52, and end radius, that is 12.25 divided by 2, it will be 6.125, and here the angle should be 360 degree, and the division along length and the division along periphery. So division along periphery is very important. You should keep this division as same to the number of division of the bottom dome slab. So in case of bottom dome slab, we keep this division as 24, so that's why we have to provide here 24. Otherwise what will happen, the note for conical shape wall will not coincide with the note of the dome slab, so that's why you have to keep it 24. And here height of this cylindrical surface, and that is 1.7, and the rest coordinate value you keep it 0 0. And now just click on this apply, and here you can see the conical shape wall, and here you can see the plate size. It's look good. If you want to change, you can change it. Suppose if I reduce this, suppose 4, now this plate size is look really good. It's almost each plate almost near equal to square, so that's why I'm keeping this value 4. And now just click on this close button, and before click on this yes, just know the node coordinate here. So here the node coordinate is 16.3, and now just click on yes, and now here provide 16.3, and just click on OK. And here duplicate nodes are ignored. As you can see that all the nodes are perfectly connect with the node of the bottom dome slab. Now I'm going to provide the thickness of it, and also I'm going to create another group for this plate. So first of all I have to select this conical shape wall. So what I'm going to do, I'm going to click on select, then I'm going to select by missing attribute, then going to select missing property, and here you can see only the missing property attribute are selected. That's mean only this plate. And just press Ctrl G, and I'm going to create another group for it, say on slab, and here this select type should be plate, and just click on OK, and just associate it. And here you can see the con slab group is associated with these plates. And now I have to provide the property, so just click on this property page and provide the thickness here, and here you can see the thickness is 300. So click on this thickness tab and provide 300, then click on assign, and here you can see the 300 thickness is assigned for this plate. Just press Shift X and just see the rendering view here, and here you can see the plate thickness is assigned. Now I'm going to model this cylindrical wall. So to model this you need to know the diameter and radius. So here you can know, here we know this diameter is 12.25, then radius will be 6.125, and also height is given here, that is 4.8 meter. But this height is not from center to center, I mean it's not from center from this beam to center from this beam. So you can calculate the exact center to center height. And also in case for this conical shape we just consider this height also, but if you want exactly accurately, if you want to model it, then you should take the from center to this center distance. Okay, so you can take that. For simplicity I'm just taking here it is 4.8, but if you want to model it accurately, then you should take this height from center from this beam to center from this beam. Okay, so here I'm considering it is 4.8 meter. And now I'm just going to open again this structural wizard, and here just select surface plate model and select cylindrical surface, and here this length should be 4.8, and start radius that should be 6.125, and also here end radius should be 6.125, and also here it should be 4.8, and this division should be 24, and division along length initially I'm keeping it 6A. So here you can see the element or plate size is good, so I am just keeping this. Just close this, and check the ordinate here. Here the ordinate is 18, so put here 18, and just you can see the cylindrical wall is created, and you can see it in rendering view, so it's okay. And also check whether all nodes are connected or not. Here you can see all nodes are connected perfectly. So now I'm going to give the property of it. So just select this by missing attribute. So here you can see I have selected this wall. Just create first the group. So name this group, suppose cylindrical wall, and this select type should be plate, and just I'm going to associate it. And now I'm just going to provide the property here, and this property should be, it is given here 250, so I have to provide it is 250 and just assign. So here you can see the property I have just assigned, and in rendering view it's look good, you can see. Now I'm going to model this top dome slab. So here the radius is given 10 meter, and for outer line the radius given 10.063 meter. So approximately I am taking here the radius is 10 meter. Okay, and the base diameter, which is 12.250 meter, and here the radius is 10 meter, so the diameter will be 20 meter. Okay, and this data is required to model this top dome slab. So now I'm going to open again this structural wizard, and here just select this surface plate model and click on this spherical surface, and here the diameter of sphere should be 20 meter, and here the base diameter should be 12.25 meter. The division along longitude, it should be 24. I'm just keeping it 6, and check whether the plate size is good or not. Here you can see the plate size is good, so I'm keeping this division. Just close this and check the ordinate here. So here the ordinate is 22.8, so I'm just keeping this is at a 30 meter height. And now I'm checking here the ordinate, so it is 37.905, and here the ordinate is 22.8, so the difference is 15.105 meter. So just press F2, and here it is minus 15.105. So just click on OK. Yes, merge all this node, and just before merging just check whether all nodes are perfectly connected or not. So all nodes are perfectly connected, so I'm going to merge, and I'm keeping the first one, I'm deleting the second one, and here I have merged all this node, and here you can see this is perfectly connected with all nodes. And now again I'm going to provide the property. So going to select by missing attribute. First I'm going to create a group for it, say top dome, and now I'm going to provide the property. The property is given 125 millimeters, so just provide here 125 millimeter. Now assign, so the property is assigned, and in rendering view you can see that the property is assigned perfectly. You can check whether all plate are connect properly or not. To check that, click on this tool and click on this check improperly connected plates, and here you can see no overlapping plate found. It's mean all the plate are perfectly connect with each other. Now we have to model heel beam and top and bottom ring beam. Let's do that. So first, suppose I want to model heel beam. To model heel beam, first you need to select either bottom dome slab only or conical shape slab only. So I'm going to select say bottom dome slab by using groove. So this is the bottom dome slab groove, and just click on this highlighted, just close this and click on this view, and just click on this view selected object only, and here you can see only the bottom dome you can see. So the heel beam will be along the periphery of this bottom dome slab. So just click on this add beam tool and just create one beam here. So I'm creating this only one beam here, and now just select this beam and then click on this circular refit, and here the number of steps should be 24 because we have divided this element in 24, as you know. Okay, so that's why I'm just keeping it at 24 and just click on OK, and now automatically these all beams are created, and here you can see that this beam is created. And now we have to give a property. First I'm making a group for it. Say this is heel beam and this select type should be beam. Just associate it and just provide the property of it. So here heel beam property is given, which is 600 by 900. It's mean 900 is the depth, so click on this define and here select rectangle and here provide this is 900, and width of the beam will be 600, so 600 millimeter, and just click on this assign and just close it, and here you can see the heel beam property is assigned here, and check it in rendering view. You can understand whether heel beam property is provided or not. Here you can see the heel beam. So this is the heel beam we just provided. Okay, and now we have to provide it the bottom ring beam and top ring beam. To do that, I'm just going to select only the cylindrical wall here. So this is the cylindrical wall, and here you can see. So in bottom this beam is called the bottom ring beam, and in top this beam is called the top ring beam. So I'm just going to create two beam, one is here and second one is here, and I'm going to select these two beam here by using beam cursor, and just I'm going to circular repeat it, and this should be 24 as you know, and just click on OK, and here you can see the top and bottom ring beam is created. So I'm making different group for them. This is for bottom ring beam, and say I'm naming it bottom ring beam. This should be beam, and this is for top ring beam. I'm going to create top ring beam. Okay, I'm just going to provide the property. So this is for bottom ring beam. Just click on this property page, and in drawing here you can see the bottom ring beam property is given, which is depth is 600 and width is 650. So here this depth will be 600 millimeter and width will be 650 millimeter. I've just provided, and for top ring beam this dimension will be 350 by 350. I can define the property, that is 350 by 350. Just assign it, and okay, that's it. See it in rendering view. Here you can see the bottom and top ring beam I have just created, and also I have provided the property. So now our model is ready, and also we have to add different component. Like for stair we have to we have to model those beams and columns, you can see here. So this model we have to do, and also for walkway we have to model this plate, and also for here. So this part I have covered in next video, as this video is going to be a lengthy video. So in next video I will show you how can we add this beam and column, and also which model you need to consider in your STAAD model, so that you can apply all the load like stair load, the load from which is coming on this walkway. All these things I will cover in the next video. So if you find this video is very helpful for you, so please like this video and share it to others, and also subscribe my channel to get this type of video in future. Thank you.